All right, hello everyone. So today we're going to do part 2 of our infinite solution and no solution systems of equations. We talked about this and what it would look like for graphing, but I wanted to talk about what it's going to look like for substitution and eventually elimination will look the same as well. So let's take a look at our infinitely many solutions first. Okay, so once again, infinitely many solutions means our lines are going to be the same. They're going to be constantly touching each other, so they will have infinite solutions. They still mean the same thing, they're just going to look a little bit different for when we're doing it for substitution and elimination eventually. So, systems have infinite solutions if you get 0 equals 0. Let me redo that. There we go, 0. So, if you go into this and you start solving it, if you end up with 0 equals 0, you know you're going to have infinitely many solutions. So, let's take a look at this one that we have here. So, we got y equals negative 2x minus 1. I know that's what my y is equal to, so we're going to take that and plug it in for this y here. So when we do that, we're going to end up with 4x plus 2. Instead of my y, I'm going to put in this whole thing. So we got negative 2x minus 1, and it's going to equal negative 2. Awesome. All right, so now from here, we're just going to start solving. So I'll give myself some room. Looking at this, we have a set of parentheses. So I want to distribute. So we got 4x still, and we got positive 2 times negative 2. That'll be a negative 4x, my bad. There we go. And then positive 2 times a negative 1. So that'll be a negative 2 equals negative 2. Okay, next thing I see is that we have x's on the same side, so I'm just gonna combine those two. So that'll give me 4x minus 4x. 4x minus 4x, that's just gonna be 0. And we still have a negative 2 equals negative 2 here. Okay, so both my x's are gone. All right, well, now we have negative 2 equals negative 2, so I'll just add 2 to both sides. So that'll get us 0 equals 0. Basically, you know that you're going to have infinite solutions when you get to this step here, and you see the same number equal the same number. You could stop there, or you could get all the way to the end where it's 0 equals 0. Either way, you're going to know it's going to be infinite solutions. Okay, cool. So that's those. You could just stop there. You don't need to find your y or anything because you already know that this is going to be infinite solutions, so you can't really find it anyway. All right, so let's move on to our no solutions. So no solution problems. No solution systems are going to get a number equaling a different number. This is going to be a different number. So let's say you got like 3 equals 2. This would be a no solution. You need to have 2 different numbers, like 4 equals 5 or something like that. 2 different things. So let's take a look at what that would look like with this. Okay, y equals 3x minus 2, so I know that's what I'm putting in. That's going to go in for my y. So I'm going to rewrite this. We got 3. But instead of y, we're going to put that whole thing at the top. And then the rest of it is going to stay the same. And we're going to start solving. So I'm going to start with my distribution right here. So we got 3 times 3. That'll be 9x. 3 times a negative 2 is a negative 6. Minus 15 equal to 9x. Okay, I see we have these 2 numbers here. Let's just combine those. We got a negative 6 minus 15, so that will be a negative 21. Okay. And then I see we have 9x on both sides, so I'm going to move one of these over. So I'm just going to say minus 9x, minus 9x. Okay. So then we're just left with negative 21 equals, same thing happened. We got 9x minus 9x, so that's going to be a 0. Okay. These are two different numbers. We have a negative 21 and a 0. These two are not equal to each other. They are not equal. So that means we're going to have a no solution here. Okay. Cool beans. So that is our infinitely many and no solution problems. Like I said, we've talked about this before in the context of graphing, but we have talked about this when we did our solving as well in topic 1. So this is just a refresher. This is a reminder of what those look like. But that's about it for this one. All right, have a good day, y'all.